Test. Hello everyone, welcome to the OneClass channel. My name is Andrew and I'm a university student studying mathematics and statistics at University of Toronto. And today we'll be going over some commonly asked mathematics questions at both the high school level and college level. And if you need some homework help or tutoring, check out the links in the description below. So now let's jump into our question. Right. So the first question is asking us how to add a whole number and a proper fraction. Oops. I'll just move this part a little bit down. Cool. Okay. So before actually talking about this question, let's first define what are whole numbers and what are proper fraction. So whole numbers just a set of numbers including 0 and counting numbers. So examples could be 1, 2, 3, 4, 5, 6, 7, or maybe also 0 included. And in terms of proper fraction, so this is a fraction that is less than 1. That will be the first condition, and the numerator is less than denominator. Right. So proper fraction, it has two conditions. First, it has to be less than 1, and also the numerator has to be less than the denominator. In other words, the top number has to be smaller than the bottom number. So some examples could be 3 over 4, 2 over 3, 10 over 1,000, yeah. Or let's say just a 1 over 2 for now. Okay, so now we know what whole numbers are and what proper fractions are, so we can do our calculation. So we want to adding a whole number and a proper fraction. So the first thing, we just simply combine the whole number and the proper fraction, which means we're just adding them together. And after we got our result, this combined fraction will be called the mixed number. Okay. So in case a mixed number is converted to an improper fraction and multiply the denominator by the whole number plus the numerator, and the result will be the numerator and the denominator is copied as denominator. I'll write this sentence down first and then I'll use the example to explain. A mixed number is converted to an improper fraction multiply the denominator by the whole number plus the numerator result will be the numerator and the denominator is copied as denominator. Right. So I'll use an example to explain. Let's just see the junior tutor's example. So we had 2 over 3 and 5. So we just simply combine the numbers first. So 2 over 3 plus 5, we'll write it as 5 and 2 over 3. And if we want to convert the mixed number to an improper fraction, we need to multiply 3 and 5, and the result will be added to 2, and the 3 is copied as an denominator, since we already have a 3 in our question as denominator. So 5 times 3 is 15, and 15 plus 2 is 17, where 17 is our numerator. So our final answer will be 17 over 3. And also there's another way of explaining this. So we still have 5 plus 2 over 3, right? And now we want to maintain 3 as the denominator, since we already have a 3 in our question. So we want to convert 5 into some sort of fraction that had the denominator as 3. Or in other words, we want to convert 5 to a fraction that at the bottom with 3. And so we just move 3 to the left side. So we have 5 times 3 is equal to k. So k will be 15. So now we convert 5 into 15 over 3. So as you can see, we have 5 here, and also 5 is equal to 15 over 3. So our question actually converted to 15 over 3 plus 2 over 3. Since we have the same denominator, we maintain as 3, and we do the adding on the numerator, which will be 15 plus 2, and give us 17 over 3 as our final answer. So either way works. Yeah. So let's leave a comment here. Great work. And that is correct. Good job. Okay. Okay, so coming up, we have our second question. It asks us, what is a fraction? Okay. So a fraction is a number that represents a part of a whole or piece of something. So it is written as the form. I'll just use point form to explain this question. The form A over B, where A represents numerator, where B represents denominator. And also, let's define numerator and denominator. So the denominator of the fraction is the divisor, which tells us the number of equal parts the object is divided into. Remember, it's always the equal parts. And the numerator, it just simply shows the part we have, or the number of parts we have. Right. So let's use the junior tutor's example. Let's say 4/1. Okay. So here's the denominator tells us the object that is divided into 4 equal parts, and the numerator 1 tells us that we take one piece or one part out of our 4 equal parts. So just imagine there's a cake, and first we divide it into 4 equal parts. Let's say 1, 2, 3, and 4. And now we only want to take one of them, one piece out of the whole cake. Let's say we take number 2 out. And this number 2 is representing the 1 as a numerator, and 4 is just our whole cake, which includes 4 equal parts. Right. And coming up, we have the 3 different types of fractions. 3 types of fraction. So which are proper, improper, and mixed. Right. So proper fractions is just when the numerator is less than the denominator, and also is always less than 1. Okay, so some example could be 1/2, 2/3, 3/4. Yeah, so fractions like this, we'll call them proper fractions. And improper fractions are where the numerator is greater than the denominator. Okay, so some examples could be 8/7, 7/6, 3/2, yeah, or say 100/3. So those are what we call improper fraction. And we also have our mixed fractions, which are a whole number is combined with the proper fractions. So recall the whole number is just 1, 2, 3, 4, 5, 6, like this. And proper fraction is what we just defined. So mixed number example of mixed fractions could be say 2 and 2/3, 6 and 4/7, and 8 and 5/9. Yep. So these are the three different types of fractions we have. And yeah, I think that's it for this question. Let's leave a comment there. Good job. Correct. So coming up, we have our next question. So it asks us to write 0.1 as a fraction in simplest form. Right. So first, let's just recall 0.1. We can also call it 1/10, and it just simply means 1 in 10. And I'll write it down, 1 in 10. Oops. So just imagine we have a cake and we cut it to 10 equal pieces, and we only take one of them. So it's just simply 1/10. And since this fraction is already in its lowest term, or we say the simplest term form, and because its numerator is already 1, so we can just express 0.1 as 1/10. Right. And I'll just expand a little bit more. So we know 0.1 we can rewrite as 1/10, and 0.01 we can rewrite as 1/100, and 0.001 we can rewrite as 1/1000. 0.0001 we can write it as 10,000. Right. So there's a little trick that whenever we're asked to convert a decimal to a fraction form with 0.01 forms like this, all we need to do is we can count how many zeros in front of the number. Like in this case, we need to count how many zeros in front of 1, and when we convert it to fraction, it will be the total number of zeros after 1 in denominator. So we have 1 0 here, so it's 1 0 in the denominator after 1, and we have 2 zeros here. We also have 2 zeros here. We have 3 zeros here. We also have 3 zeros here. We have 4 zeros there, and we also got 4 zeros on the denominator. So just a little trick. Right. I think that's it for this question. Good job. Oops. Oh, correct. So our next question. Okay. It's asking us to find out the value of tangent 60 degree. Let's copy down the diagram first. So we got a triangle, right triangle, XYZ. 21, 42, 30 degrees, 60 degrees. Right. So first, before jumping to these questions, I would like to first recall some formulas we always use in trigonometry. Right. So the first thing I'll be talking about is the SOHCAHTOA. SOHCAHTOA, which is simply stands for sine, cosine, and tangent. So for sine is equal to opposite over hypotenuse. So that's where the SOH comes from. And for cosine, it will be adjacent over hypotenuse. And that's where the CAH comes from. And for our last tangent, we have opposite over adjacent. Right. So by knowing this, I'll be introducing the basic model in trigonometry, which is this triangle here. Let's see x, y, z. Yeah. So this is the basic model in trigonometry, and remember, as long as it has a 30-degree angle, a 60 degrees angle, and a 90 degrees angle, its hypotenuse is always 2, and the two other side will be √3 and 1. And note that we can always multiply each side by some number, while the right triangle maintains the same property, which means it maintains its same angle. I'll write it down here. Multiply each side by some number. The right triangle will maintain the same property. Right. So in other words, if we times each side by 2, we'll have 2 plus 2 is 4, 1 plus 2 is 2, 2 plus √3 is 2 √3. And we call that 1. Yep. And in this case, since we times each side by the same number, in this case will be 2, so we still have the same angle, which here will be 30 degrees, 60 degrees, and 90 degrees here, right? So by knowing this, we can move to our actual problem. So we need to solve for tangent 60 degrees. So let's use the TOA relationship. Recall TOA means tangent 60 degrees is equal to opposite over adjacent. Right. So we already have the value for our adjacent side. I'll copy down the graph. Yeah. So now, since it's asking for the tangent for the 60-degree angle, we only focus on angle x. Right. So we already have the value for our adjacent side, but the value of opposite side is missing, which means we're missing yz, the length of yv. Right. So we'll apply the Pythagorean theorem. I'll write it down here. Apply Pythagorean theorem, which is, I'll just write HYP as a short form of hypotenuse. Square is equal to base square plus vertical square. Right. And now we move base to the left side, which we have hypotenuse square minus base square is equal to vertical square. Oops. And so because we want to know what vertical is, so we take a square root on both sides. So let's a hypotenuse square minus base square. Since we root square a vertical square, so the 2 is cancelled out. So we have vertical left. And now we are just need to substitute in our known values. Substitution. So for vertical will be equal to root. We have 42 as our hypotenuse minus 21 as our base. And 42 square will be 1764, and 21 square will be 441, which is root 1323, which we can rewrite it as 21 root 3. Yep. So now we have everything we need to calculate the tangent. We can write 21 root 3 here. So we have our hypotenuse 42, adjacent as 21, and opposite as 21 root 3. So let's do the tangent. So the tangent 60 is equal to opposite over adjacent, which in this case our opposite is 21 root 3 and our adjacent is just 21. So we have our tangent 60 degrees as root 3. And I also remember when we just introduced the basic model, we can always use that to check. So the triangle in this questions is 42, 21, and 21 root 3. And our original basic model is 2, 1 root 3. So you can tell it just simply times each side by 21. So because 1 times 21 will be 21. 21 times 3 will be 21 root 3. 21 times root 3 will be 21 root 3. And 2 times 21 will be 42. So our answer is correct. And so our tangent 60 will just be opposite over adjacent, which give us root 3 as our final answer. So roots, yep. Answer is correct. Good job. Okay. So our next questions is asking us to find out the solutions of x squared is equal to negative 13 x minus 4. All right. Okay. So in these questions, we notice that we are not be given the what we call the standard form of quadratic equation. So we need to convert to that first. So we just simply move everything on one side and leave a 0 on the other side. So in this case, it will be x squared. Since it's negative 13x, so it becomes positive 13x to the left side. and this is -4, so it will become a +4 on the left side as well. So we only have a 0 on our right hand side. And now it follows the form of ax squared plus bx plus c is equal to 0. And the reason why we're converting this is because we want to apply the quadratic formulas. And yeah, so let's how we apply the formulas. So x will be equal to negative b positive positive negative root b squared minus 4a times c over 2a, right? So we know in this case a is equal to 1, since because ABC is just a coefficient of these three terms. Oops. And b is equal to 13, and c is equal to 4. So let's substitute the number in. So x will be equal to 2 times 1, negative 13, would be 13 squared minus 4 times a, which is 1, times c, which is 4. And let's simplify that. 2 times 1 is just 2, and we'll use negative 13 there. So 13 squared would be 169, minus 4 times 1 times 4 will be 16. Right. So we have negative 13 root 153, right, over 2. So our two solutions will be x1 is equal to plus 153. Negative 13 minus 1 root 153 over 2. It doesn't matter what the order is. You can also say negative 3 minus root 153 over 2 will be x1. It doesn't really matter. Okay. And before jumping to next questions, just want to have a couple things to mention. So always remember to convert it to the standard form whenever you want to apply the quadratic formula. And also there's going to be another type of questions ask you how many solutions there are there. And also you can use this way to check your answer. So remember this part. At the beginning when we apply the quadratic formula, b squared minus 4ac, right? So after we calculating b squared minus 4ac, if this number is greater than 0, we're always going to get two different roots, x1 and x2, where x1 is not equal to x2. And also, if b squared minus 4ac is equal to 0, we're still going to get it. We're still going to get a result. But this time, we have x1 is equal to x2. So they are same roots. And also the third situation will be b squared minus 4ac less than 0. Right. So in this case, we conclude x1, x2 does not exist. Yeah. So in this case, you can tell the 153 is definitely a positive number, which is greater than 0. So we have two different x1 and x2 here. Right. So let's see what the junior tutors got. Negative 13 plus root 153 over 2, right? Negative 13 minus, right. Answer is correct. Good work. Well done. So coming up, we have our next questions. Name the major arc. Find its value. So I'll just copy down the graph first. Oops. C, A, and B. That's 50 degrees. All right. Okay. So we need to name the major arc and find its value. So first, let's recall the definition of major arc. Major arc. It is greater. Major arc is always greater than semicircle, which is just meaning it's more than half circle, and it's equal to the central angle. So that's first greater than semicircle. Second, it's equal to the central angle. So in other words, it just means the angle of a major arc is greater than 180 degrees. And in terms of naming the major arc, we are just using it. And we call the arc CDB, which is the same as arc BDC. It's they're representing the same thing. And also, a circle completes in one revolution, and so its measurement is always 360 degrees. So we can do our calculation. So arc BC plus arc BDC is equal to 360. There's another color. Right. And since we know arc BC is equal to 50, so we can substitute the 50 into there. So we have 50 minus arc BDC is equal to 360. And we just subtract both sides by 50, or we just simply move 50 to the right hand side. We have arc BDC is equal to 360 minus 50, where arc BDC will be equal to 310. Which means the degree of our major arc is 310 degrees. So just write a conclusion here. So the major arc is arc BDC, and the measurement of arc BDC is 310 degrees. Right. So that is our final answer. Let's see what the tutor's got here. Arc BDC, measurement of arc BDC, right. All correct. Good work. Okay, our next question. It asks us the center of this circle copy down the graph first. E, C, B. Okay. Oh, right. So in this question, the center of the circle is at point A. And so the name of the circle is determined through its center. So the name of this circle will be circle A. And I'll just introduce some other commonly used names in circle as well. Okay. I'll draw another circle, just for better explanation. Right. And so first, we have circle, let's say circle K. And there's a line cross circle K, and within the circle, and this is what we call diameter. So this is diameter. And then half of the diameter, it is what we so-called radius. So in this case, if we got point A, point B, KB will be our radius, and AB will be our diameter. And also we got here, if we got a CD. CD is what we call the chord, which does not cross the center of the circle. And also we have, oops. Right. So as you can see, the red line here is what we call the tangent. You only cross one single point of the circle. Right. So those are some common names or terms we use in circle. Okay. And so the center of the circle, what is center? Right. So we'll leave a comment there. So coming up, we have our next questions. We need to solve the system of equation. So we have y is equal to x squared plus 10x plus 11. Y is equal to x squared plus x minus 7. Right. Okay. And we want to find what x are and what y are. Right. So whenever we come across questions like this, since we have two variables here, x and y, we always want to cancel one of them to figure out one variable first, and then we'll substitute back into the equation to figure out the other one. So in this case, the most obvious way of getting rid of one variable will be we just use left-hand side minus left-hand side and right-hand side minus right-hand side. Since in this way we can get rid of y in order to have only one variable left. So by saying that, we use our left-hand side minus left-hand side and right-hand side minus right-hand side. So we have y minus y is equal to x squared plus 10x plus 11. We just copy down whenever it's there. Oops. minus x squared plus x minus 7. Right. So just remember, because there's a subtracting sign, so we just put the second part of the equation into bracket. So we have for y minus y, which is 0. And now we can get rid of the bracket. We have x squared plus 10x plus 11 minus x squared minus xx, since it was plus sign in the brackets, but now when there's a subtracting sign in front of the bracket, we need to change the signal of it. And the negative 7 will become to positive 7. So as you can see, we got a positive 2 and a negative 2, which also means x squared minus x squared. We can get rid of that. So we only have 0 is equal to 10x minus x, which will be 9x, plus 11 plus 7, that'll be plus 18 total. So now we only have one variable left, which is what we want. So let's just solving for x. We minus 18 on each side. So 0 minus 18 plus 18 minus 18 will be given 9x is equal to negative 18, which means x equal to negative 2. Right. And so now we have the answer for variable, which is you substitute back in either one of the equation to figure out what y is. So let's do let's substitute to the second equation. That's equation 1, equation 2. So we have y is equal to, so instead of writing x, we'll just use negative 2 squared plus negative 2 minus 7. So we have y is equal to 4 minus 2 minus 7, which were given y as negative 5, x is negative 2. Oops. Which is our final answer. And whenever you come across a question that asks you to solve the system of equation, you can always, after you getting your final result, you can always substituting back into the original equation to check if your answers are correct or not. So in this case, I'll just copy down the original question. Right. So now we can substitute x is equal to negative 2 and y is equal to negative 5 back into the equation to see if left-hand side is equal to right-hand side or not. So let's see. So we got negative 5. It's just another color. So the first equation will be negative 5 is equal to, instead of writing x, we just write negative 2 squared plus 10 times negative 2 plus 11. So the right hand side, don't write the equation sign yet. So negative 2 squared will be 4 plus 10 times negative 2 will be negative 20 plus 11. So this also is negative 16 plus 11, which will give us negative 5. So now you can see the left hand side is equal to right hand side. So the our answer for the first equation held. And now let's check the second one. So negative 5 is equal to negative 2 squared plus negative 2 minus 7. And after calculating that, we have 4 times minus 2, minus 7, which give us a negative 5 on the right hand side as well. And left hand side, we still got a negative 5. So in this case, that means our answer is valid, and you can always use this way to check your answer. Right. So let's see. X equal to negative 2, y is equal to negative 5. Correct. So it's correct. Good job. Oops. Okay, I think that's a wrap for today's session, and yeah, and thank you all for joining us today. And if you enjoyed today's Q&As and would like to be notified of when we do this next, please hit the subscription button and notification bell below. And if you would like to submit your own questions, we did the links in the description. Remember to leave a comment or like and share this video with your friend. And this has been Andrew from OneClass. I hope to see you soon. Bye.